in-place sorting versus out-of-place sorting. The difference between in-place sorting and out-of-place sorting lies in the way memory is utilized by the algorithm. So in case of in-place sorting, what happens is the elements are rearranged within the same data structure that you had provided as input. So if you provide an array as input to an in-place sorting algorithm, then what it will do? It will do some rearrangements of the elements that are in this array, but it won't use any extra space for doing this sorting. Then it is called in-place sorting. See, when I say it won't use any extra space, it may use constant extra space. That is, it may use some variables that are required for sorting or something. So it may take constant extra space. But my point is, the additional space that is used, that won't increase proportional to the input size. So there is no relation between the input size and the additional space that is used. So it may take some extra space for some initialization of variables or something. That is okay. But the whole data manipulation, that will work totally inside the given data, whatever is the input data. This is when you call it as in-place sorting. When is this useful? This is useful especially when the data set is very large. So if you have very large data, it is very useful that it won't use any extra space and it will do all the manipulations within the given space. So this is where in-place sorting is an advantage. And what about out-of-place sorting? In case of out-of-place sorting, the algorithm may need additional memory. And why will it need this? It may create some new data structure and it may copy data to there, and maybe it will do the sorting there. So if you give one input array, if this is your input array, what an out-of-place algorithm may do is that it may first copy complete data set into some other place, which makes its working easier. And maybe from this place it will do some rearrangements, or it will take one more additional space and then do some copying. This is all out-of-place sorting. So in this case, additional requirement is additional space which is in some proportion of the given input space. Okay. So this is called out-of-place sorting. So when we look into sorting algorithms, we'll see a lot of in-place algorithms. Many like bubble sort is an in-place algorithm. Quick sort is an in-place algorithm. Selection sort is in place. Insertion sort is in place. So you'll see a lot of in-place algorithms as well as out of place. So merge sort is out of place, counting sort is out of place, and so on. So when we go into those lectures, you'll be very clear on how exactly it is in place and out of place. So why we are having this lecture here is, I want you to have the concept in your mind, the idea in your mind of what is in place, what is out of place. Then when you look into those algorithms, you will be able to clearly understand that, okay, this algorithm functions in this manner, and because of that it is in place. Because of this it is out of place. So that is why we are having this lecture before we head into the algorithms lectures for those particular sorting algorithms.